Hi guys, welcome back. So today will be our last day that we will get to practice our favorite F word. Ready? Factor. Alright, so let's do this. So a quick reminder, a general approach to factor polynomials. First things first, regardless of what technique you use to factor, whether you use the one that we have been talking about or the one you discovered on your own, the prerequisite step is always to watch out for common factors. Now, what if you have a binomial and there's a minus sign in the middle? Okay, so the recommendation is first to check to see if you have difference of squares, and if not, difference of cubes. Now, what if you do have a binomial but there's a plus sign in the middle? If that's the case, you're going to aim straight for sum of cubes. What if you have a trinomial? Do what you gotta do. Okay, if the leading coefficient is 1, you're gonna go ahead, throw down parentheses, work on getting that first term, and then do what you gotta do to complete those binomial factors. If we have a trinomial and the leading coefficient is not 1, then we're gonna go ahead, use the AC method. Okay, so if I remember, I'll put links to the other videos. Now, what if you have a trinomial and the numbers look pretty big? Then we do what we gotta do to see if it's a perfect square trinomial. Cool. So remind me to put links to those videos. Okay, so let's go ahead and look for our final installment in the factoring unit. We're gonna do 3 spicy problems and then we're out. Okay, so the directions read, let me cover my solutions. Okay, the directions read factor completely. Okay, first things first, when it comes to factoring is we need to watch out for common factors, but these 4 terms don't have any factors in common other than 1, so we're good. So now, how are we gonna handle it? I forgot to read our 4th item. If you have a 4-term polynomial, then go ahead, factor by grouping. Okay, so no GCF, we have 4 terms, we're gonna factor by grouping. To facilitate the process, I'm going to show you the 3 times that I failed. Then together we will write how to do it. Okay. If we have a 4-term polynomial, we're going to factor by grouping. Okay. So the procedure usually goes like this. Okay. We're going to group the first 2 terms, group the last 2 terms, take out the GC. Let me zoom in. Okay. We're going to group the first 2 terms, last 2 terms, take out the GCF from each team, and then hopefully the binomial factors match. But in this case, they don't. Okay, so that's it. So now, usually we group the first 2 and the last 2, but sometimes that doesn't work. Sometimes we just have to group it differently. Okay, if grouping the 25c squared with its neighbor didn't work, why don't we group it with another term thereafter? Why don't we group it with the number 4? Okay, so we're going to group the 25c squared with that other term, and then that will leave us with negative 20c and negative d squared. Okay, so we grouped, but we still have teams of 2. So we look at the first team, GCF is 1. We look at the second team, GCF is 1. And unfortunately, the binomial factors still do not match. Oh, I'm having a problem. Okay, grouping the first term with the neighbor didn't work. Grouping the first term with the neighbor thereafter didn't work. For the final time, let's group the first term with the 3rd term thereafter, namely the d squared. So we're going to regroup. We're going to take 25c squared and group it with the final term. Okay, so we look at the 25c squared and the minus d squared. They don't have a common factor of 1, but they do have a special relationship. Okay, so we have a difference of squares and it factors as such. Okay, looking at the last 2 terms, the ones that we grouped, namely the leftovers, negative 20c and 4, GCF is 4. When we factor it out, we have the binomial of 5c minus 1. And unfortunately, we don't have a common binomial factor to take out. So I usually tell my students, you know what? If at first you don't succeed, try again. Okay, we grouped the first term with the neighbor, we grouped it with the neighbor thereafter, and we grouped it with the final term. So in the normal circumstances, I'm like, okay, that's it. There's no way to regroup it. But check it out. This is not a first year in algebra. So this is why we got to make it spicy. Okay. So we're going to regroup a little bit differently, but it's not going to be the traditional 2 terms and 2 terms. I want to point out that the last term in the polynomial is a perfect square. Okay, so we have a d squared, square of something, and there's a minus sign in the middle. Wouldn't it be nice if we had a perfect square in the beginning? Who knows? Okay, let's just pretend that we do. Okay, well, scratch that. Let's just group it differently. This perfect square term, we're gonna group it by itself, and then we're gonna group the first three terms. What I want to get at is this: when we factor by grouping, we say factor by grouping because that technique involves grouping terms. Typically we make teams of two, but right now we're gonna have to do a 3-in-1 thing. Okay, so if we group the first three terms, now we have a trinomial. There's no GCF to yank out. The leading coefficient is not 1, so we're gonna use the AC method to factor. Okay, so let me go ahead and do an X game above, and we want factors of AC that add up to B. Okay, so let me label my A, B, C. Okay, we want factors of AC that add up to B. Product of A and B, namely 25 and 4, is 100. Remind me to give myself more space. Value of B is -20. So I'm like, okay, what are factors of 100 that add up to -20? And in this case, factors of 100 that add up to -20 will be -10 and -10. So remember, the gist of the AC method is to split the middle term so you can have 4 terms and then factor by grouping. Okay, the variable part of the middle term reads C, so when we split it, we will replace it with -10C minus another 10C. So let's do this. So we're cool with the first term. The middle term, that's the one that has to get split. So minus 10C minus 10C, and then we bring down the rest of the problem plus 4, and then the minus D squared. Don't forget, we grouped the first three terms. Oh, you can't see that, sorry. I forget that just because I can see my own writing, it doesn't mean that you can. Okay, hopefully you saw everything else. Okay, so we grouped the first three terms, which we split into 4 terms so we can factor by grouping. Okay, when we group the first two, we're gonna go ahead factor out the common factor, which is 5C. That will leave us with first term over common factor. That will leave us with 5C. Second term over common factor, that will leave us with -2. And I can't even read my own writing, so I don't think I should have done the long brace. Okay, but I can't erase it, and I don't want to redo this video, so I'm gonna do another brace like this. That is not a brace. Oh my gosh, we have like a, come on, see, we have a flying bird. I should just restart this video, but oh no. Okay, I'm gonna just leave. Yeah, I can't bounce back from that. Okay, I improved it. It just looks ugly. All right, cool. So let's go ahead and look at trinomial that we split. So that where we split the middle term, because we're factoring using the AC method. Sorry. Okay. Looking at the second group, I want to know what is the greatest common factor. In this case, 10C and 4 have a common factor of 2. But remember what I said, when you take out a common factor, it's to your advantage that when you do, the first term you're left with is positive. Who cares if the rest are negative? So for that reason, we're going to factor out a -2. Let's take our time. First term over common factor, -10C over -2 will give us 5C. 4 over common factor will leave us with -2. Close the grouping symbol and then bring down the rest of the problem. Okay, so let's not forget that we are factoring by grouping, but it's not the conventional 2 versus 2. It's going to be a 3-in-1 thing. Let's go ahead, continue to finish factoring that trinomial. Let's go ahead, in this case, factor out the common binomial factor of 5C minus 2. And then we will show the reader what we're left with when we factored from that expression. First product over common factor, the binomials cancel out, and that will leave us with 5C. Second product over common factor, the binomials cancel out, and that will leave us with -2. Let's go ahead, bring down the rest of the problem. Cool. So I wasn't quite sure where I was going with this. It's just I saw a perfect square at the end and the minus in the middle. I was like, I don't know, maybe we have some squares, who knows. But in this case we do. We're gonna go ahead write the product of the binomials using exponents for repeated factors. Okay, so at this point we don't have a binomial, but we do have a binomial like expression, something minus something, so two somethings. We have a binomial like expression. So fake binomial minus in the middle, I'm gonna ask myself, do I have a difference of squares? And if the answer is no, then we go straight to cubes. So do we have a difference of squares? In this case we do, because we got the square of 5c minus 2 and the square of d. Let me go ahead, wrap the d in parentheses, okay, just so I can see the base. So I'm going to remind myself, if we have a difference of squares of the form a squared minus b squared, then that will always factor to a plus b times a minus b. It's not because Torres said so, it just comes from your algebra. Again, this is just the multiplication shortcut but backwards. So in this case, the first base is 5c minus 2, that's our a. The second base is d, that's our b. So if this is our question, then this is our answer. So the expression should factor of the form a plus b times its conjugate. So we have a, which is our first base, plus b, which is our second base, multiplied by the conjugate, first base minus second base. Cool. And I think we're good. So I boxed it prematurely was because I trusted myself. So the directions were a factor completely. So again, factor, that's code for write me as a multiplication problem. I want to know, can we factor more? The degree is 1, so the biggest exponent is 1, and we don't have a common factor to yank out, so we're good. Okay guys, so I said we were going to do 3 problems. This is the first one. We got 2 more, so let's do this so we can be out. Okay. Alright, so let me zoom out. Okay, let me go ahead, write down problem. What's after A, B? Okay, problem B, we have x squared plus 16x plus 64 minus 9y squared. Okay, fantastic. Okay, so first things first, can we take out a common factor? The answer is no. Okay, so because we have 4 terms, we will factor by grouping, but before we group the first 2 and the last 2, let's see if it's the one where we have to group in a special way. So what I like to do to see like a heads up, should I do a 3 versus 1 or 2 versus 2? I like to see if we have a perfect square at the end. Okay, in this case we do, because 9y squared is the square of 3y. Do we have a minus before it? So I'm like, oh, perfect square minus before it. Wouldn't it be nice if we had a perfect square in the beginning? In this case, wouldn't it be nice if this was a perfect square trinomial? So let's go straight to the special grouping of 3 versus 1 versus 2 versus 2. Okay, so let's go ahead, factor by grouping, but we'll do the unconventional grouping. 3 terms, 1 term. So let's do this. Let's focus our energy on the trinomial. Trinomial, is the leading coefficient 1? It sure is. Okay, so that means that we don't have to use the AC method. Let's go ahead, throw down parentheses, work on getting the product of the first terms. So we want to get that x squared, so namely x times itself. And to complete the binomial factors, we want factors of c that add up to b. If you don't need it labeled, then I don't need it labeled. Okay, but we want factors of 64 that add up to 16. If my eyes don't fail me, I think it's 8 and itself. But if you're like, no, Miss Torres, I don't trust you, I have to stop saying my name. Okay, if you're like, nah, we need that x game, then go for it. Okay, we want factors of c that add up to b. Okay, so it's 8 and 8. Okay, so we only split the middle term if we use the AC method. Bring down the rest of the problem, minus 9y squared. Okay, so let's go ahead, use exponents for the repeated factors. So we have square of x plus 8 minus, while we're at it, let's go ahead, write 9y squared as a perfect square. 9y squared is a perfect square because it is the square of 3y. So the question that we wanted to ask ourselves, do we have a difference of squares? Okay, question mark. Yeah, So we have something squared minus something squared. The answer is yes. Let's identify the bases. Our first base is x plus 8, so that's like our A. Our second base is 3y, that's like our B. So let's go ahead and factor. Difference of squares of the form a squared minus b squared will always factor to a plus b times its conjugate. So if this is your question, this is your answer. So if this is our question, let's go ahead and bust out the answer. So this should factor to a plus b times its conjugate. X plus 8, so a, that's the longest a ever, plus b, multiplied by a, which is the first base, minus b, which is the second base. We have factored. There's no GCF to yank out. The degree is 1, so we're good. Okay, guys, so I said that I'd owe you 3 problems. This is the second one. Let's go ahead and do the third one so we can be out. I know you're sad. So if you want to say the F word again, factor, go for it for old time's sake. Okay. So the third and final problem, we have m squared minus 14m plus 49 minus 169n squared. Okay, so let's just watch out for common factors. We don't have any, we're good. We have 4 terms, so let's factor by grouping. So again, the traditional grouping is 2 terms and 2 terms. But the reason why I'm going to go straight to a 3 and 1 grouping action is because the last term is a perfect square and there's a minus before it. So maybe we have once again an undercover difference of squares like we did with the other problems. So 169n squared is a perfect square because it's the square of 13n. Okay, wouldn't it be nice if the first 3 terms gave us a perfect square trinomial? So let's do this. We got a trinomial. Leading coefficient is 1, which means that we don't have to use the AC method to factor unless you really like it. Okay, leading coefficient is 1. Let's go ahead go straight to throwing on parentheses and work on getting the product of the first terms. The product of the first term should give us m squared, and we're going to use variable times itself. To complete the binomial factors, we want factors of c that add up to b. So we want factors of 49 that add up to negative 14. And if my eyes don't fail me, I think it's 7 and itself. Well, negative. You know me, I put the numbers first and then the signs thereafter. At this point, I'm jumping for joy because we have the same binomial, which means that when we use exponents for repeated factors, we will have a perfect square. So the question that I wanted to ask myself was this: do we have a difference of squares? Okay, and the answer is yes. Okay. So if we have a difference of squares of the form a squared minus b squared, if this is our question, that's our answer. So let's claim our answer. The first base is given by n minus 7 and the second base is given by 13n. So again, if this is our question, this is our answer. So this should factor to n minus 7 plus 13n times n minus 7 minus 13n. We have factored. Okay, we have a multiplication problem. The degree is 1. The biggest exponent on any of the variables is 1. There's no common factor to yank out, so we're good. Thanks, guys.